Hi. We've got about 2 hours right now. Let me check one message. Nothing crazy here. All right. So here's the plan for right now. We are going to get as far as we possibly can on this code cleanup for the new prioritized experience replay implementation. And that's it for today. That's the only plan. And tomorrow we will continue and hopefully finish or roughly finish said cleanup. Trying to remember where we left off, so where I should start with this. Is there a way to see sample reuse? I wonder if there's a way to see sample reuse. We could technically add a log variable. Is there anything better I can do? I would like to be able to have some stats about prioritization. I can't think of a better way of doing this at the moment than logging reuse directly. Maybe what we do is we log it and then we decide whether it's a useful metric, right? Okay, so we have ep uses. Sample. IDX. So we do data.ep uses of idx plus equals 1. That's fine. And then I think we have to zero some stuff out. Ep uses. Okay, so we do ep uses. I guess I can zero it, can I? Yeah, I can technically zero it. So mean and log of data is there. It's the easiest way to do this. Data.stats.keys. I think this will do it for now, right? That's weird. That is a tensor. Dot float. Okay, so this now runs. Should still train. And we do have to log on Neptune to see this, because I didn't hook it up. But then we should be able to see the priority buffer usage. And we may or may not keep this stat. I don't know, we'll see. Okay, so here is our run. Yeah, and we have data. Holy. That's a lot. Mean usage is at 32. I don't think that makes any sense, does it? Let's do it without Neptune. So these sum to 128. This is reprioritize experience. This is wrong, isn't it? You compute JE up here. So you need to do this outside of the loop. Kind of interesting that that does anything. But anyways, we'll just move this. Let's make sure this still does something. Wait, isn't this still wrong? No, this is good. All right, so .5 max of 22. That looks better, right? Okay, let's redo this with logging and see if this is the expected result. This 32 doesn't make any sense. Oh, you know what? It probably got accumulated over all the batches or something. That must be it. Is this still training? Or is it stuck now? That's sketchy. Okay, so this does worse than the bugged version. It's always the favorite. Let me think about what it did when I had it up here. So when I had it up there, it would take the top n rows and it would reprioritize, right? Well, hang on, it shouldn't even be using that buffer at all, right? I guess this would give it... No, that can't do anything. Let's just figure out how the heck that happened. We definitely had it working a second ago. Okay, we have 16K advantages. We have 16K. Okay, so the last ones are empty. So you see the advantages are empty here, right? The last advantages are empty. $16, 384. That is 1,000,000 batch size. Which is correct, actually. That is correct. So, I guess what we want to do is go here. That's not an impossible index, right? 8192 is the biggest index. Yeah, so this is fine. How can this possibly change anything? I think this just upweights the probability of getting a top sample. I mean, we can pretty easily test that, right? See if this trains. And then we'll do top K instead of sampling. Yeah, we just call top K on this. So we'll go to sample. So instead of multinomial, we just do there it goes. It literally knows. Okay, so this is a solve. Now let's see what happens with top K instead. I do that right? Okay, so that's crazy. So top K is very different from a sample. Doesn't work with top K. See if we can figure out why. Hmm. Those are the indices. Here are the values. Oh, well, this means you're only going to train on these. Right. Because I'm not actually computing this correctly. Okay. Let's do some updates to this then. So the trick here, the values need to get recomputed, right? All the values need to get recomputed, actually. Well, that's a problem. How do we recompute all the values? I mean, we can definitely recompute the values of the ones that we sample. Maybe that's enough. I guess we have to return indices, right? Okay, so we have batch here. Where's new value? Right here. Where's experience dot values? batch.idx. Something like this. So that's 128 by 64. So that's not good. We don't want it to flatten. That now works. Okay, that's slightly annoying. Well, we're gonna punt on this for now. We'll just do this. All right. Trying to backward through. So compute JE. I guess it tries to do some weird stuff with this. Trying to backward through graph second time. Where? This? Oh. Probably this assignment has a grad. That's learning faster. See how long it takes to learn the full thing. Adding mask after first neural net got me 550 to 675. Not bad. Not bad. Still funny that the other one is so much faster. That could just be the, I mean, neural nets don't like to do tiny matrix multiplies. Neural nets, I mean, graphics cards don't like to do tiny matrix multiplies. Yeah, holy hell, this is like immediately better, isn't it? Turns out when you implement the algorithm correctly, it does better. What are you up to? I'm implementing prioritized experience replay for PPO. Look at that, max uses. So it's deciding to use some samples here like 70 times. Mean usage should always be 0.5, right? Oh no, wait, 32? Alright, so this is scaled weird, so we'll have to check this out. So it's like 2x usage. Now we see whether with this change, top K, let's see if top K still breaks it. We would suspect that top K should no longer break it. But we could be wrong. Oops. Much better than before. Not learning anywhere as quickly as the other one, though. Interesting. I wonder why that learns so slowly. It's not like it isn't working. It is, it's just... The updates are stable, too. It's just really slow. Well, I guess we keep the sampled version for now. But this is not where it should be implemented either. So we compute this here. Can I move this out at least? Can I move this to where it's supposed to be over here? Or does this still break it? Okay, so yeah, at least unless it gets stuck, it looks like that at least fixed it from it fixed that issue. It'll perform very similarly. Cool. So that fixes it. Mean usage is 32. Yes, that makes sense. Wait, 32. No, that doesn't make sense. Max uses on both of these. It's very low. That doesn't make sense. Oh, 0.5. I think I asked this before, but for multiprocessing, what conditions would I like to use 8 workers, 8 M's, instead of just 2 and 2? 8 workers, 8 M's, instead of just 2 and 2. When you're hard bottlenecked by the end. So you'll have to use a larger batch size to do that, because to get the same rollout length, you need to take more steps since you have more M's. But going from 2 cores, 2 workers, was it 8 workers and 2 M's? Yeah, going from 2 cores to 8 cores, that goes from single buffered up to 8x buffered, which you pretty much never 8x buffer. At most you like quad buffer. So it wouldn't be like 8 workers, 8 M's most likely, unless you have M batch size of 2. Yeah. The numbers are a little off there, Spencer, but you're increasing the amount of buffering, which decreases env overhead. You maybe think about that when your env is slow and you can't speed it up. Oh, man. Oh, okay, I see. So at most, a sample gets reused like 6 times, is what this is telling me. 8 times, 9 times, depends on the run. Cool. And we can actually comment this portion as well. And then we'll see how it does without the experience buffer. So this should be without replays. Does it just do better? It's kind of funny. It is possible for it to just do better. Yep. Now we can adjust that as well. That could just be too much off policy data. Weird that it does that. It does floor division. But doesn't actually cast. Okay, so now this is a substantially smaller buffer. I think this still might be slower. That's still slightly slower. What's like the per run variance look like on these though, I wonder? Does it just get lucky? Or is it pretty consistent? This does worse. Okay. You would think having a very small replay buffer would do something helpful. So far, we're not seeing it. We can always sweep that, though. Alright, that's not bad. It's still slightly below, but this is reasonable. And then we can sweep this, right? We can definitely sweep this. Okay, so that gives you your replay factor. Next. I guess we can compare it to a random sample, right? Prioritize versus random. Oh wait, this is... Yeah, 1 and 2 advantages. That's correct. Huh. Wouldn't it be funny if this ends up being better? Okay. On par with prioritized. It's kind of funny. So, lots of different sampling schemes to try. Obviously, we're not going to conduct all our experiments on breakout. That would be incredibly stupid and limited. We do want to get this to a point where we can start running those real experiments, though. What if we run this thing on big mazes? One big maze, even. Map size is 31. One map. What about this? Unexpected keyword seed. The heck is wrong with this? All tensors must be on GPU. Oh, well that's obviously going to happen. I guess I screwed something up with this end. That's unfortunate. Does it happen with more maps? I just like screw that up? No, I broke something with the end. That's really weird. We have the scythe on too, don't we? I merged something bad? Map size 31. Are there any other M's I can think of where this would help a lot? I think this is kind of the one, isn't it? Does password still work? Yeah, I need to fix this one as well. Well, I think that that's the obvious M to try this on, so we're not going to be able to do anything until we fix that. I could port it real quick. But I don't think I want to do that right yet. Okay. We'll do some other stuff in the meantime. So I think update epochs. Can be a little bit different here. Mini batches times config update epochs. Goes back to 1. Okay, there you go. That seems faster than before, right? But the obs or whatever, it doesn't optimize quite as fast. Oh no, that's good. That's close to the original solve time, actually. Original optimized best solve time. Why does this not show up? Oh, did I not run Neptune? That works either way. Yeah, I didn't run Neptune. That's fine. That works. So the only difference is now epochs can technically be a fraction, right? I could say run half an epoch, and that means that you only touch each sample half a time on average. Copy bandwidth is brutal. Definitely we'll have to optimize that. Okay, this overall is decent. Let's see if neural MMO3 runs. It does run. It runs at half the speed it used to run at, though. We'll definitely have to check on that. This is definitely an end where prioritized experience could help you, though, right? Yeah, definitely. So we have that. We can do that overnight. I'm tempted to just queue that right now. Right, queue that experiment. Why don't we do that? Oh, we need to modify grid. Uh-oh, is the network super slow? No, it just used all the freaking disk space. Well, that sucks. We have to figure out that bug for sure. That's a tomorrow me problem. Yeah, that's not going to respond. Yeah, I don't know why those files would be so big. All weights. That looks like a versioning difference. Been wanting to ask you what you think about RLHF. I mean, it's language model specific, right? People are now doing like full RL, not just RLHF. Well, not really full RL. They're still kind of doing a very pale imitation of RL. The latest thing is multi-turn RL, which literally means RL that's not just a single time step. Like LLM-RL, the results are going to be very impressive just because they've been doing zero actual RL before. But like they're really, really doing a tiny, tiny fraction of what RL can do for you. How is this file so big? Not necessarily restricted to language. Base knowledge is domain-specific reward model. I don't really know much about RLHF, but from what I've seen, it looks like you're establishing a borderline supervised problem, except you don't, instead of having the supervision, you only have like A is better than B or whatever. I mean, like the classic, like which is better, response A or response B, right? Like that's, you can see how that's a very, very tiny fraction of what we do with RL, right? With RL, we have long series of interactions, and you sporadically get often a very sparse reward, right? You can see how that's a very different setting. If you could run, like, if you had the data and the scale to run RLHF or anywhere near the number of samples we do in actual RL, you just solve everything instantly, because you basically have, you don't quite have supervised learning, but you have something that's a lot denser than what we usually have in RL. And that still seems big. I'm talking about the setting where your reward model is not a human feedback. Well, you said RLHF, right? It's our reinforcement learning from human feedback. Talking about any base model and any general reward model over an arbitrary number of steps, then that's just what you think about RL in general, and I do that all day. Like, what specifically are you asking about? Starting from a base model? Well, if the base model isn't particularly large, like they did that as a crucial part of OpenAI 5. There was a whole bunch of net surgery stuff to warm start the model so they could run more experiments. So, when they eventually ran it from scratch, it did just as well. If you mean as a distinction, what about when you use a larger model? Yeah, you're going to be able to do a lot of stuff. If you have a pre-trained language and vision model, it's going to know language and vision, and you're also going to need thousands and thousands of GPUs, which I don't have, right? Reward function is not learned from the data. That is not a thing. That's what happens in RLHF. Not as far as I'm aware. In RLHF, you have human feedback, right? The human feedback gives you the reward signal. Like the classic example, right, is you have two completion candidates. Is A better than B? Learned preference model from human feedback. That's just an approximation of, that's just a smooth interpolation of the actual training data you have for the feedback model. I don't think there's any hack here that gets you like infinite learning yet, or whatever. Like it's literally a classifier. Yeah, but that's just that's just a supervised model then over the data set that you have. I don't think that gives you infinite scaling. I'm actually kind of frankly surprised that we haven't gotten infinite scaling yet. It seems like it should be pretty easy, but evidently not. Like, why can't I just take any half-decent coding model, right? Anything that can really output anything at all. I'm surprised RLHF works. I mean, it doesn't really work as well as the full RL, from some of the recent stuff. But I'm kind of surprised that something like that hasn't gotten us infinite scaling. Like, why can't I just take GPT-4 and say, become a better programmer, and give it access to a compiler or whatever, and just let it rip, right? Why can't I do that? Works for me. I can do that. Don't they already try to do that? I have no idea. I don't follow the frontier model stuff, right? My job is to fix RL. At least that's what I've made my job. There are thousands of people currently attempting to make language models work. There is one person actually trying to fix RL right now. Me. And the proof of that is if anybody else were seriously trying, then I wouldn't be able to make RL like 1,000 times faster in a year. Because you really have to be trolling for to be doing something at like 1,000th of the speed that is possible. In some ways, it's generous for me to say nobody's trying. Interesting distinctions. One, the reward models learn from the data. Okay, I don't think that the way that that's done in RLHF really matters that you're learning a reward model. Process starts from a good base model. Yeah, that matters. I want to see this extended to non-language tasks. I'm tired of language, man. Well, but this is the thing, right? Your base model doesn't really help you on unintuitive tasks that aren't really heavily language or vision grounded. That's the issue, right? Like, think about it. What's a base model do? A base model tells you how language and vision work, and arguably somewhat how reasoning works. But that doesn't help you that much when you have a new fancy unintuitive task. And you're paying the price of running a gigantic model every time you want to, run a sample. Imagine one that learns crude physics from sensor data. You would need a really fancy tokenizer trained on a lot of different types of sensor data to make that useful generally. Look, language and vision are the two easy ones, right? There are a lot of images and videos, and there's a lot of text. And they're in roughly the same format. It gets way harder when you go outside of that. People do specific stuff, right? People are training models on like, was it 3D modeling data? They're now like 3D model generators or whatever. But like, just getting arbitrary sensor data and making something useful with that, that's really hard. Realizing that, yeah. The thing is, if there's nothing to be a foundation of, then your model doesn't really do anything. If it's not a foundation for anything, you can't really do much, right? Why is this model so big? Maybe I should make this work weights only. You said you don't think the reward model being learned is important. Partially the reason why LM can reward hack so easily. Well, I don't think it's like... I don't think it's massively useful, is all. If you're learning like supervised reward function from the data, I doubt you're learning something massively more useful. Like, you're probably not doing anything that's more useful than just asking the language model which one it thinks is better, which is like the point, anyways, of what you're training it on. It's a chicken and egg problem, I think. I don't know. RL is fundamentally chicken and egg too. No, it isn't. Our rewards come from the environment. We're not asking the model what it thinks the reward is. We're giving it one. It's very explicit. Value function or policy from scratch. The value function is informed by rewards that you get from the environment, and the policy is going to initially get random data. Yes, you have to initially luck into getting a reward or you don't learn anything, right? But it bootstraps from there. As soon as you start learning, the policy is no longer random. So it's not chicken and egg, it's like random and egg or whatever. There's a big difference though. That's still way better than what you're doing in That's still way better than like assuming that RLHF would infinitely scale. This does infinitely scale, right? RL does infinitely scale. It just takes a lot of compute, and you have to get bigger and bigger models and all of that. You need a lot of samples, but it does infinitely scale. Exponentially badly in some cases, but it does scale. See the paper about 1,000-layer RL policies? I don't know why everyone cares about that thing so much. What's the point? Was it even model free? No, it's self-supervised. Yeah, this is like... That doesn't make any sense to me. Like, why does this matter? See, this increases performance 2 to 50x if you do not care how long it takes and you would only care about samples. And it doesn't work in, like, this is only self-supervised. I don't even know if this is really novel, to be honest. Like, world model type stuff already scales to 200 mil nets. Also, these tasks are really easy. Yeah, I don't know if there's anything useful from this actually at all. I've had like 4 or 5 different people cite this paper to me being excited, and I don't know why. What did I screw up? Paper from 6 days ago. If you replace the Go Burr 1,000 layers with just recurrent depth, aren't in the depth dimension. No, it wouldn't. That's a thing. I worked on that a while ago. So that's a hyper network. No, not a hyper network, a highway network. My bad. That's a highway network. And one of my, actually my very first paper, my very first published paper was this one. Recurrent highway hyper networks. Tiny little amount of code. This is what qualified as NIPS research back in the day. It was soda. technically. But the thing is, you have a fixed parameter budget, right? You can't just do infinitely as well, infinitely good by applying those same parameters over and over. You can do better, but not infinitely good. And I would expect that to be especially the case with the smaller RL networks. You'd be very limited. They're much better. That's a smaller file. Okay, that should fix the blow up issue. Just looping hidden state. So you're looping like billions of parameters there, right? You're looping like a million parameters in the RL case. You're very limited by that budget. Rediscovering RNNs. That's literally what a hypernetwork does. I mean, not a hypernetwork, a highway network does. No, just looping a layer. Yeah, that's what a highway network does. It reuses the same weights over and over again. It uses tied weights. So you like unroll, you just do the computation with the same weights like 8 times or whatever, and that's an 8-layer highway net. Pretty darn sure, at least, that was what it was. It's been many years. I checked that really easily because I have the implementation. Oops. Why does this have 150 stars? Are people actually ever using this? Function. Yeah, you see? Oh, wait, am I wrong? Yep, I'm wrong. These aren't shared. Huh. I remembered these being shared weights. I guess these aren't tied weights. Maybe I tried that originally. Yeah, it would be reusing this several times. My bad. It's literally just this if you replace this logic with one cell instead of having it be cell of L. It's like a 2-line change to this. There we go. Here's our agent playing Breakout very, very fast. I mean, you're free to try it, and if you want to try it in an RL context, like, Puffer is very fast. It's like this for a reason. It's so that we can try lots of stuff. Kind of cool to see how well the RL just works now. Look at that. This should be a perfect score breakout. Yeah, there you go. All right, so that should fix the load problem as well. I guess what we do is we just start the line by line, right? Make losses. What's an environment you want to really see solved? Neural MMO 3. When we have Neural MMO 3 solved, if we do it without a whole bunch of janky bullshit, probably Puffer's ready to just, like, solve a few hundred valuable problems in industry. NetHack is probably AI complete, and it's easy on paper to run RL at scale on it because it's really fast. but there's some janky stuff that prevents you from running enough copies of it in parallel to actually train fast on it. So it's actually kind of hard to like run that at scale. Somebody could go fix that and it would be really cool though. I also don't think that like your average person and certainly your average person and definitely or maybe even your average researcher isn't going to appreciate how truly complex of a problem NetHack is. You can run multiple instances of it on separate processes. Yes. Now go try running like 4,000 instances of it on a machine and getting training going at 1,000,000 steps per second. That's where the difficulties come in. I can run a 3 mil per ram net on neural MMO at like 500k steps per second already. What's the technical bottleneck for scaling NetHack? It's the fact that it uses globals in C. So apparently it's actually really hard to get multiple instances of it onto the same process. If you could just get like 1,000 instances of NetHack on one process and run those in a loop in C, like that should be very fast. Yeah, that's literally it. No, fuck Rust. Rust is an awful language. Fuck that. Ugh. It's not C, it's just, I think it's just that it uses some weird globals and stuff. If they weren't using weird globals, it would be fine. It's not the language, it's just like the way it's written. Okay. That runs. I'm not a Rust enjoyer. I have like no desire to ever interact with that language. Which sucks because I know like there are some good programmers in that community, but it's not for me. uh, how'd you learn about the globals problem? Over drinks with one of the NetHack devs at NeurIPS. Put on the cat ears. God damn it, no. It's just the opposite of everything I like about programming, right? I like shit that's like, really concise and simple and doesn't get in your way, and Rust is just like a big freaking bloated language with a million ways to do everything that has very strong and very dumb opinions about how you should write everything. It's just not let me just enjoy my C, all right? Let me just enjoy my C. Still writing M's from scratch in C. Yep. I haven't personally written. No, I did write one like a month or two ago, 2 months ago ish. I wrote the maze grid env, and then of course all the contributors were still writing everything in C. I'm telling you, it's very easy. C has just been very maligned. It's like, it's so incredibly, incredibly easy. It's really just a joy to write code in, especially for this like specific stuff. It's great. And now that we figured out how to get around Cython, so we don't even need Cython anymore, it's like peak perfect. It's like peak coding experience. There's a lot of setup code with this, isn't there? Barrier prevents scaling NetHack as a legacy code engineering. Yeah, it's legacy code engineering. I haven't even tried to like bother messing with it, frankly, right? There's some other stuff you'd have to do with NetHack as well, which has mostly been done, to be fair. Like for instance, somebody has the thing that like renders it or whatever, each character into a pixel, which is kind of useful. You kind of just want the ob space to be like with height num channels if you can. And there's some stuff that's a little tricky with that, like the bottom line message. You can't really do that with. But that's mostly solvable. Like you could definitely have something pretty fast training on NetHack. Actually, Ryan, who just defended his PhD, did a lot of work around NetHack, but not as deep into the engineering as like we do with Puffer here, right? Like I don't think he went substantially into the like the underlying C or anything. Sullivan. He is Navalis in the Discord. Magikarp profile guy. He's cool. Ah, we no longer need this. Perfect. I was like looking at this, like, do we need this? Ah, we don't need it. Num mini batches. Do we need this? I don't really think we need this either, to be honest with you. The fuck? When did you add Muon? I've been hard at work here, man. Does it work for RL? Yes, it kicks ass. It gave us a step change in capabilities. It solved every single environment in Puffer out of the box with almost the same set of hyperparameters, except the really hard ones. And so far, we've doubled Soda on Neural MMO with it. I think we can just do this. Config batch size. There we go. You probably need to assert the, yeah, there's probably like an assert that you need, right? We'll keep doing checks later. Does it still run? That works. Okay. I think I like that a little better. Okay. Next. GPU N by D, CPU N by D. This seems fine. I don't know if there's a simpler way of doing that. I guess I could have the backend return you a slice. That might be worse. I think we do this for now. Mask still needs to get fixed. What about H and C? Let's see, because it needs to have like partial. Yeah, this needs like partial buffer. I can do this. I don't know if I like that. Yeah, see, I don't like that because then it puts the index not in the profile MISC. Alright, so if I leave that for now, this is just the first pass after all. Don't ignore, we ignore these, we get the reward clamp, state LSTMH. Then we store it. I think you need both of these. And you no longer index this, do you? This is just going to be on the right device. That's easy. Where do you use NVID? Just for stored indices, it looks like. A few other things. Dest, though, is definitely not. Yeah, we no longer use any of this stuff. Let's update it. Gonna head out, have a nice one. Have a good one. See you around. I'll be back first thing tomorrow as well. Oh, hey, YouTube folks. We have a fair few people watching me at 8 p.m. on a Tuesday. Hi. We're currently cleaning up our implementation of prioritized experience replay added onto PPO. Mainly cleaning up the dev branch a fair bit, aiming towards a big release soon, and absolutely cannot release with the code in this state. We've just got way too many dev features that aren't cleanly integrated or anything yet. There we go. That looks like we can clean some stuff up here as well. So, end. I think this is no longer needed. So these indices, yeah, so these indices we definitely need to handle masks on, don't we? But that's all. Yeah, data pointer, we don't need this. Okay, so we get copy indexing for contiguous n by d. Here. When you store with n by d, what do you store with? GPU n by d. Does that make sense? So I think you want to convert this to a slice maybe, right? This is already going to be a slice though, when this comes in. So if this is already a slice, you should not have to do this. Data.stored indices of batch rows. Ah. I see, because you can't assign a slice. Yeah, you can't assign a slice. Okay, that's fine. Goes down here. See if this still runs. Yeah, we're still good. Didn't break anything. Reward should already be on the right device. And then this should already be on the right device. Let's see if that works. Yep, that does work. And then what about this done? Okay. D right here, D. Where do we get D from? I thought that this is supposed to be non-Boolean. Oh, it is Boolean. The more you know. That's totally fine then. I think we can do of mask. How do we do this then? Of mask. I didn't break anything again. Slice object not subscriptable. Lovely. So we just do not going to fiddle with that just yet. If instance. Okay, this is two places that I have this. So we have env ID. Ep indices, ep lengths. Is this no longer worth using a slice? Wait. Hey Linky, welcome. I'm going to bed pretty soon. How's it going? I assume that that's going to be star puffer. So thanks for the reminder. Folks, if you want to help me out for free, just start the repo, puffer.ai. Really helps us out a lot. We're trying to hit 2K stars. which is a really large amount for an RL project. Back to code. How's progress on XBuffer? It trains. It works. We really need to clean up this file. Honestly, the two biggest things making it messy are E3B, and diversity is all you need, though. How do your eyes not get tired coding so late? It's only 8-something p.m. here. I'm going to bed pretty soon. I've also kind of been doing this my whole life, so you get used to it. And not only am I staring at the coding screen, I'm actually staring at this big ring light up here as well. Deep diving tail scale docs to see if I can figure out potential causes of the latency on a few of the boxes. If it's box 0 and box 4, it's because I fucked up the checkpointing logic, and they're currently both out of disk space. So I'm probably going to have to figure out how to get into those and delete some crap. Possibly might have to figure out just nuke the Docker container and rebuild it. That is why I originally wanted to have the Docker container only be 95% of the storage space, so this couldn't happen. Some kind of screen dimmer. I do have a screen dimmer on. Actually, it should be getting a little yellower here. I don't know if it shows on the stream or not. Yeah. Can you index? Oh, there's no way to slice this anymore, right? Yeah, I think I gave that up with the current implementation. Maybe a mistake, we'll see. How's training perf? It's good so far. I mean, I've been just training on breakout, right? But we've got some good breakout runs. 1.5 million steps a second. It's good so far. Box 2 is showing derp server timeouts. Pull the new puffer tanks and rebuild them. Accepted my PR to it to limit usage. Perfect. So, Lean Key, actually, we probably need to really upgrade the tanks because there's a dev branch of puffer tank that has new torch and stuff on it that is needed for the dev branch. Do you end up doing per sample priority or just trajectories? You cannot do per sample priority with an LSTM. It doesn't work. You have to do trajectory segments. I came up with a reasonably clean way of doing it, though. I don't see how per sample would be that useful. It just doesn't work with LSTMs. It's been tested to not break 2.0 M down for an update to support dev. Yeah, I think it's going to be like, well, we definitely need to fix those boxes, but literally all that happens is we can remake the same containers and those boxes will work. Not even like rebuild the Docker, literally just like wipe the container and just make a new one. Takes 5 seconds if we can actually get into the machines. And then we'll apply yours when we really redo all those boxes. Speaking of which, the boxes are going to get shipped pretty soon to the new facility, which I think I put the picture in the chat, right? The new facility. That's pretty solid looking, right? 40 outlets, Ethernet to all of them. Continuous actions didn't do well. Yeah, we'll have to look at that. There's a lot of stuff to look at over the next couple weeks. A lot of stuff to look at. Invite of full. So we want to use the slice ID. I think how we do this cleanly. We want to use slices whenever possible, but then all this big indexing here is not going to be able to be sliced, right? Could be a problem, come to think of it. We should be able to have this be faster though if there are some special cases. Well, I guess for now we'll just do what we do. Short function's getting shorter. This isn't going to work without a slice, is it? If I just put this down here, this breaks, right? Or no, maybe it doesn't. Does indexing work that way? The fact that that's way longer is scary. Seems good. Episode indices, episode lengths, and free index. Is there any way we can reduce some of this? I don't think so. Hang on, maybe there is. Yeah, there might be a way of doing this better. The problem is that it would result in very long trajectories for slow M's, which is a problem. That's definitely a problem. Yeah, the common use case here, actually, we can simplify quite a bit. So if we're assuming we always have a large number of parallel M's, and we're only getting one trajectory segment per nth, then we do not need to keep track of episode indices. We can potentially very much simplify episode lengths. But the problem is, like, if we only store one trajectory segment per environment, and we have like Atari with 24 environments, then we're gonna have 24 giant trajectory segments. And that's not gonna be good for batching on the GPU. It'll be very bad, actually. And there would be no way around that either. Yep. I think we have to leave it this way for now. I might think of a way to improve the general case, but I think otherwise we're gonna get screwed by yeah, we're gonna get screwed by this. Legacy code, making our life hard yet again. Like, really, if I could really make this very, very simple if we just assume like everything's a puffer env. I guess we have to deal with this for now. Oh, at least we were able to keep the GAE implementation simpler than I thought it would be. Okay, so sample, a few different options we're playing with. We've got this stat that we're playing with for now. Compute PG loss. We were gonna play with like torch compiling stuff like this, right? Or torch compiling the whole loss section, maybe. I don't think we need this for now. We can always get this back. We don't need this for now. Mean and log. Epoch. Yeah, so we can simplify a little bit. This goes. What I do? We should actually see learning rate being kind of cool on here, right? Yeah, that's the... It doesn't do a very good job of it. It's supposed to be cosine annealing. I guess it doesn't have enough updates or whatever. Yep, that saves a little bit. Make sure I didn't break it. Looks good. What does this mean here? Mean and log. Okay, so there's a little bit of logging shenanigans. That's not a big deal though. Keep looking for stuff to cut. This file is getting to the point where, like, really the main things that are making this a mess are just E3B and diversity is all you need, because these are like two optional switches that we don't know if are going to be broadly useful or not. So if neither of them are useful, we just delete both of them from the code base. The code base gets a lot shorter. If either of them are like really good and impactful, then we we just keep them and we don't have the switches. And if they're like sometimes very useful and sometimes dead weight, well, then we have to refactor and think about how to like do this a little bit more cleanly, because this is a freaking mess. But the rest of the code is getting to be tolerable, we'll say. Definitely tolerable. Get rid of some comments. Again, we have all this in the old version. P3O also. We haven't finished P3O. Gradient variance. May or may not keep that. Let's see how we're using, how our train loop looks though. Oh yeah, these things. This should go at the end of sample, shouldn't it? I think I can just put this at the end of sample. I mean eval. Yeah, so that'll do it. That also lets us get rid of these super jank statements from here. We have like this really jank. Yep. Okay, that's better. Here it still trains. I don't like how we're handling these losses. Not terrible though. Accumulate mini batches. B cross entropy Okay, so here is the real meat of it, right? You compute generalized advantage estimation. Num samples equals mini batch size over BPT horizon. This can go up here. Then the state just like this. I have this reshape. LSTM logic is a bit of a mess. You know what we can do? We can put this in the model. Since we have forward train now. And we can do this. And that should still run. Yep, there you go. That's a little better. No longer need these device synchronize. Yeah, no longer need that. We fixed that in the profiler. Not a big fan of the way we do this reshape either, honestly. I can't think of a way around it, but I really don't like that we have to check whether the policy is an instance of an LSTM here. Don't think about that one. Okay, we sample logits, that's fine. Train missed, this is where we do all the losses. We're gonna have to do a big investigation into clipping with PPO. I'm actually suspecting the clipping doesn't matter as much as one would think. Funnily enough. Policy loss. Okay, the rest of this is pretty clean. What about the scalar thing? I can do something like this, right? the gradient variant. This is to do delete after we're done with it. You got your gradient clipping. Doesn't Heavy Ball have gradient clipping built in? Let me see. Gradient clipping, string or function, update clipping, gradient clipping function or method. See Heavy Ball utils for available options. Yeah, don't give me a 2,000 line file for available options, my guy. Adaptive gradient clipping. Let me just ask Lucas which of these gradient clippings I should use. Let's see, what is this adaptive? What's it actually do, though? This code's kind of silly. Know why it's written this way, but it's kind of silly. Well, we can leave our current clipping for now. It's one line. Optimizer step. Otherwise, data scaler, that step, data optimizer, and data update. Okay. Is there not a data, like a width for this? This is Torch AMP. Why is there no scaler here? Do you need this? Do people use the gradient scaler? Interesting. Okay, we'll leave this for now. But sudo can remove scalar if only using BF16. Okay, now here are all the losses. Definitely we can simplify like some of this accumulation logic. We've got it in the losses, we've got it in a couple places. So we know we can do that. And what's this config target KL? What's this goes, okay, yeah, this is correct. I was just making sure we had it indented. And then we reprioritize experience like this. Data scheduler step. Use P3O. PyTorch have like a null scheduler. See scheduler. No. Just keep this. Explain variance needs fixing. There's really not that much more code here. Get rid of these. Get episode return updates without clogging the dashboard. Know how to do that. We do full. Did we ever call this? I think it was just full. Fine. Now store functions relatively short, sample functions relatively short. It feels like we've made a dent in this. We're down to 1161 lines. There's definitely quite a bit more to shave off. But that's good progress. And that's a good spot to call it, I think, for today as well. This is what we're going to do. Not breakout, clean PufferLib, demo. Cleanups. That's nice. That's minus 100 lines with that commit. What do we have in neural MMO3? Looks like we have reasonable stuff here, yes. Then I think what we'll do just so we get a partial run-in on this overnight. Okay. It is slower somehow than before, and I don't know why, but you know, that's for tomorrow. Cool. So lots of good progress today. I am planning on being back first thing in the morning pretty much, and most of the week as well. Most of the next several weeks. A lot of work was going to happen over the next bit. So if you want to follow all of that, all my stuff's at puffer.ai. If you want to help me out for free, just star the GitHub repo. That's all I ask. Really helps us out. We're trying to hit 2K. If you want to get involved in dev, whether you have RL experience or not, join the Discord. If you want more RL content, you can follow me on X, where I post some threads and some articles that you can't find anywhere else, though we do have a blog here as well. Also restart box 7. I don't think I can do that remotely. Yeah, I don't. Okay. We're gonna have to do some stuff on all the boxes tomorrow because we have several of them that are misbehaving. Okay. Well, thanks, folks. I'll be back probably like first thing in the morning, so.